Hello participants. Rocks on the Earth surface undergo physical, chemical and biological weathering and produce sediments. Sediments may be transported by the action of water, wind, glaciers and by the force of gravity. Rock weathering and sediment formation, transportation and deposition, soil formation and erosion of soil and eventual transport to sea are the part of Earth's rock cycle. These processes happen at different scales in a watershed and are regulated by a combination of various factors on the Earth's surface. Deposition and subsequent transformation of sediments give rise to soils in a watershed. Sediments may remain resting at a place of the weathering and over the period can transform into a in situ soil layer. Sediments deposited by rivers due to loss of energy or gradient give rise to the ex situ soil layers. Upon entering a stream and during a downward journey, weathered rock fragments are known as fluvial sediments. Heavy rock fragments move along the riverbed and form the bedload of a river. The lighter parts remain suspended in the turbulent flow and are referred as suspended sediments. The term suspended sediment typically refers to solid coarser than 0.45 micrometer in size. Finer materials is considered dissolved if one disregards colloidal matter. The process resulting lowering of the surface of the land by mass wasting and erosion is known as denudation. It can be estimated by calculating the total sediment discharge of a basin and by neutralizing it to the total catchment area. Sediment discharge, often termed sediment load, refers to sediment transport mass per unit time. Sediment yield, calculated by dividing the sediment flux by drainage basin area upstream of which discharge is measured. It means that the sediment flux is normalized for the basin area. The sediment yield refers to sediment delivery averaged over the area of the entire drainage basin. Rivers connect continental interior to the oceans. World rivers discharge 36,000 billion cubic meter of water and carry 14 to 18 billion ton of suspended sediment and 3.6 billion tons of dissolved load to the ocean annually. Rivers also carry products of terrestrial biological processes and anthropogenic activities to the coastal seas. Various natural and anthropogenic processes and factors regulate the transport and flux of sediments and dissolved loads. It is almost axiomatic to state that sediment erosion and subsequent transport are controlled by drainage basin size and topography, gradient, bedrock geology, climate, rainfall, severity, vegetation cover and anthropogenic activities. The basin variable used in the universal soil loss equation. Erosion and soil production rates worldwide vary over 4 orders of magnitude depending on local site characteristics, particularly climate, geology, soil, topography and vegetation. Let us talk about soil and soil erosion. Soil is a complex mixture of rock-forming minerals, moisture, content, air and organic matters. It covers the top few centimeters to a few meters thick to the land and acts as a Earth's skin. Our entire food production system is mainly dependent on the fertile soil cover. This soil layer supports the vegetation cover of the earth and it shelters a variety of microbes, insects and other creatures. The soil along with the water, vegetative cover and livestock are the prominent natural resource of every watershed. Soil erosion is a natural process associated with the geomorphic processes or agents such as running water, wind, coastal waves and glaciers. Besides, human and animal interferences also led to soil erosion in a variety of ways. Soil erosion represents the process of detachment and transport of sediment particles by geomorphic agents. The top layer of the soil is prone to detachment and transport due to falling raindrops, surface runoff, and windstorms. Detached soil moves down with the help of wind and water and deposits at another region. Learners, soil erosion may happen in different ways. Raindrop splash is the first stage of erosion and happens due to raindrop hitting the barren soil layer. Sheet erosion is a uniform removal of soil cover from the land surface by wind or slowly moving water. Rill erosion is a form of water erosion in which numerous small and more or less straight channels or streamlets are produced. Gully erosion is a form of water erosion in which gullies are produced by combining unattended rills. Gully erosion occurs due to the heavy runoff caused by rills to widen and deepen. Ravines of Yamuna and Chambal have been formed in this manner. Stream banks are eroded by water either flowing over the sides of a stream or scoring at the base. In the coastal areas, sea waves, tidal waves, and tsunamis dash along the coast and cause heavy damage to the soil. It is called littoral erosion and it's most intense along the Kerala coast. In the high altitude areas of Himalaya, glacial action causes soil erosion on a large scale. The removal of soil particles by wind is called wind erosion. Wind erosion is active in arid and semi-arid areas which are devoid of vegetative cover. Soil erosion by wind erosion is common in Rajasthan and adjoining areas of Haryana, Punjab and Gujarat. Weathering, transportation of sediments, soil formation and soil erosion are the natural processes, and in the absence of human interventions or mass wasting processes, they occur at a slow rate. The geological or natural erosion rate refer to the rock and soil removal rate from the land surface of a drainage basin measured as mass removed per unit of the time under the natural settings. Estimates of global average erosion rates for the past 500 million years range from 0.016 to 0.024 mm per year. The current soil erosion rate is about 13 to 40 times faster than the natural rate of erosion. Approximately 40% of the world's agricultural land is seriously degraded now. We are literally mining the soil for food. The scientific evidences points to the fact that modern civilization through agriculture has caused a great accelerated rate of erosion on the world's productive agricultural lands. Erosion rates from the conventionally plugged agriculture fields average 1 to 2 order of magnitude greater than soil production rates. Erosion under native vegetation and long-term geological erosion. Surprisingly, no-till agriculture produces erosion rates closer to the soil production rates. It has long been recognized that erosion in excess of soil production would eventually decrease agricultural potential of a land. Therefore, it is imperative to initiate sustainable agriculture. Soil erosion rates vary greatly across a watershed, a river basin and also globally. Each year, about 75 billion tons of soil is eroded from the land. The loss of soil resources due to erosion from a well-functioning and productive land is a recurring problem across the watershed on Earth.